Divergence. What is divergence? Divergence is the expansion outward of the origin or compression towards the origin with no specific direction. When we deal with something that is expanding out of the origin or going towards the origin, we use divergence. But there is no specific direction for the divergence. If the flux, let's say for example the flux or liquid is expanding out of the origin, then the divergence is positive. If it is compressing toward the origin, the divergence is negative. It means that if the water is coming out of the origin, then the divergence will be positive. But if the water is going inside the hole or inside the pipe, then it is compressing toward the origin, where the divergence will be negative. In mathematical perspective, we can say that divergence is equal to the product of a continuous differential vector point function and vector differential operator. So the dot product of differential vector point function and vector differential operator is a divergence. Divergence or div f equals to dot product of del and f. The output of the divergence is always a scalar quantity. How we know that it is a scalar quantity? Before to find the output of the divergence, let me give you a simple example. If we have two vectors, a equals to a sub 1i plus a sub 2j plus a sub 3k, and b equals to b sub 1i plus b sub 2j plus b sub 3k. And when I take the dot product of a and b, it equals to this value. When I take the product between these two terms, I times I equals to 1. This is mathematical rule. I times I equals to 1. And when I take the product between these two terms, j times j will equals to 1. And when I take the product between these two terms, k times k equals to 1. So the final value is here, which is a sub 1 b sub 1 plus a sub 2 b sub 2 plus a sub 3 b sub 3. It is a scalar quantity. It means that the product of these two vectors gave us a scalar quantity. Exactly the same technique can be applied for the divergence. Let me apply this technique for the divergence here, where del equals to I partial or partial x plus j partial or partial y plus k partial or partial z. Dot product of f equals to f sub 1i plus f sub 2j plus f sub 3k. When I take dot product between these two terms, I times I equals to 1. When I take dot product of these two terms, it gives us j times j equals to 1. And the dot product between these two terms, where k times k equals to 1. So finally I are left with the divergence equals to partial f sub 1 or partial x plus partial f sub 2 or partial y plus partial f sub 3 or partial z. There is no more unit normal vectors I, j and k, because both del and f had I, j and k, so they cancelled each other, and we got the final value in a scalar quantity. In other words, the output of the divergence is always a scalar quantity. Physical interpretation of divergence. What is meant by physical interpretation of divergence? It means that the application of divergence in daily life. Let's say for instance, if the water is coming out of the pipe, it is a positive divergence, and when the water is going inside the pipe, it is a negative divergence. Similarly, flux coming out of the source, it is a positive divergence. Sunshine or the energy coming out of the sun towards the earth is a positive divergence, and when it reflects back, it is a negative divergence. For instance, let's suppose that vector v is a velocity. It is an equation which shows a velocity, and when I take its dot product with the del, it equals to partial v sub x or partial x plus partial v sub y or partial y plus partial v sub z or partial z, which is a scalar output. Let me show you an example. First I want to draw the xyz plane. This is x-axis, and here is y-axis, and here is the z-axis with the unit normal vector I, j and k. Let's suppose that this is a pipe where the water is coming out of the pipe. It means that the water is expanding out of the origin, so it is a positive divergence. And similarly from that direction, the water is expanding out of the origin again. Take it along z-axis, the water is expanding out of the origin. So this is the example of a positive divergence. There is no specific direction. It is without direction. Why it is without direction? Because the output of the divergence is always a scalar quantity. When it comes to a scalar quantity has no direction. There is only magnitude with a scalar quantity. The output of the divergence is always a scalar quantity. Let me give one more example. Let's say that the light is coming out of the sun. So the light is coming out of the origin, therefore it is a positive divergence. When it reached to the earth, some of the light will absorb in the earth and then it reflect back. So when it reflect back, it means that it is going towards the origin. It is compressing towards the origin. And now the divergence is negative. I repeat it. First, the light is coming out of the sun. It is coming out of the origin towards the earth. It is a positive divergence. Again, when the light reflects back towards the sun from the earth, it is going towards the origin. It is compressing towards the origin. Now it is a negative divergence. So we can see both positive and negative divergence in this example.